Good evening, and thanks for joining me. This is video for my final project for a cs6963 visual forensics course at NYU Poly. The purpose of this project it was to create a bunch of feature extractors for the bulk extractor forensics tool. So if you're unfamiliar with bulk extractor, it's a tool used by forensic investigators to quickly scan through disk images or memory contents, whatever it happens to be, for things of interest. And so how do you define something of interest, right? And so that's what these features are. So these extractors will attempt to pull out particular things, and maybe that's relevant to someone's investigation. So the bulk of what I'll be talking about are feature extractors that have to do with money, in a sense. There's another one for driver's licenses, but that was mostly written by somebody else. I'm just taking up the mantle to update it to the new format. So to quickly run through these, I'll leave it up to an exercise, the viewer to do some Googling, just to not over-explain. But so IBAN, SWIFT, and RTN, and chips, the FedWire are essentially what we would consider more conventional means of money transfers. So those are numbers that are used to identify banks and accounts. In some cases, internationally or locally, RTN and FedWire those are really kind of U.S. Institutions. SWIFT and IBAN are international means for identifying banks and country of origin and that kind of thing. So those are kind of the more traditional forms of money transference. In addition to those, we have some features revolving around what we call web money, Liberty Reserve, Trust Cash, Perfect Money, Ucash is another one that I don't have listed there, and Bitcoin. And so, with the exception of Bitcoin, all of those others are also have a kind of a trusted third party that you create an account with and give them money, and then you can transfer that money to somebody else that has an account there, or maybe pay for goods and services with some vendor that does accept it. In some cases, some of these services provide anonymizing benefits, if you will, such that maybe if you were attempting to buy some illicit good or service, right? A criminal might think that they're protected in that. So you can see why and with that scenario that it might be important for an investigator to attempt to find maybe accounts associated with a person subject to an investigation. Bitcoin is somewhat similar in that regard, except for the fact that it's driven by a peer-to-peer network. There is no essentially trusted third party that brokers all the transactions. You may have heard Bitcoin has been in the news a lot recently, and maybe at this point considered slightly more legitimate than some of the others, but maybe not. That's for the viewer to decide. So let's go ahead and jump right into it. I'm just going to run through kind of how these feature extractors are broken up, kind of give the justification, and also go over, like I mentioned before, some of these were updates of some people's previous projects. Some of it I rewrote due to problems with false positives and what have you. And so I'll be taking some time to make sure to point out which are which, where new code starts and where some of the previous stuff came from, just to make sure everybody gets credit for what they did. So like as I said, I've kind of broken these up into several different categories. So under the e-currency one is where we're listing these kind of less traditional but trusted third party, quote unquote, means for transferring money. So Trust Cash, Ucash, Perfect Money, Web Money, and Liberty Reserve. These were two that were done previously by another NYU Poly student. These three are new, and these had some updates. I'll kind of go over those in a sec. So as you can see, so each some of these have some unique characteristics. Ucash, they have kind of a fixed format. Like header. Same thing for Perfect Money and Web Money. So for each one of these institutions, just like your bank account, they have to have some way of accounting for what belongs to you, right? So pretty much in all these cases, these are representative of the account numbers that you would have. With the case of WebMoney, you can actually have multiple accounts per. These are essentially the sub accounts that are define different types of currency that you can have. That's kind of their deal. You can have lots of different currencies with them. The only exception to that maybe is Trust Cash. They don't have an account in the same they don't have the same concept of an account as some of these other places do. For Trust Cash, when you actually initiate a transaction, and then they tell you to just deposit money into a bank account, and then they give you information where to deposit it to. There's a transaction ID that is associated with that, and so that's what this one is. So this one's not so much an account, but it does essentially lead to the same thing. Helps you identify, somebody that had a transaction through the service. As I said before, so a couple of these were previously done. The WebMoney and Liberty Reserve scanners. There was some contextual stuff to trim down on the amount of false positives. These are generally pretty small strings, so they run a pretty high risk of butting into or coming up with a lot of hits, especially on a lot of data. And I'll go through that when we look at the results and my test data later. And the WebMoney, they actually added a bunch of new purses and stuff, I guess, since the previous person had written this, so this accounts for that. So, but the rest of them are new and what have you. So, all right, so let's go on to the financial one. So, and this one is what I was calling the quote unquote more traditional scanners. So. This one does have some code that was previously written. So the RTN and FedWire are essentially are the same thing. In this case, there's the RTN code actually has a means of validating it. There's something of a kind of a pseudo checksum that's built into it. This was done by a previous Sci4 student. Just with the exception, like I said, the same thing before, adding some character stripping just to the high rate of false positives for this. So kind of limited it down to the context in which the number is picked up, because you'd be surprised, even though there is a validating algorithm, just how many false positives would fall out for this. So the chips UID. This one right now, and you can see, is really small, and there is no validating algorithm. This is kind of an old way that banks used to use stuff, and you'll see that this one has a lot of false positives. In fact, this one arguably should be removed, but just for the sake of doing what I said I would, this one is implemented, but will probably end up being no real use to investigators, just because it is such a high false positive rate. And then the last change is the Swift code. The previous implementation didn't really take into account that there are limitations in the way that the code is written, and so this one actually restricts it by ISO 3166 country codes, which are embedded in the actual number. So that does help us trim down on some of the extra stuff coming in, and also grabbing essentially the last three characters of the Swift code, which identify a branch. It's not a required part, but as an additional kind of feature. Yeah, so let's move on to the next one. So I did mention IBAN as being one of the more traditional ones, and so this is IBAN is an identifier for moving money between different countries, not just the U.S., right? And so there was a previous implementation of this, but it was a really high false positive rate, and in looking at it, it didn't really match what the spec for IBAN was really talking about. So what I've done is instead of having kind of like a too general feature extractor for it, where it just has two numbers, or two letters and then two numbers and then a bunch of other stuff. The spec is actually pretty good in calling out, so each country is it's up to them to define what happens after these first four characters. And so it's easy to write a real general one, but you're also going to get a lot of extra stuff from your scanner when you start looking at a lot of data. So what I've done is essentially is implemented the entire IBAN format in its own detector by country. So yeah, so you can see the list here is pretty long for all the countries. The other thing is that these are implemented. They're written as such so that what they consider their electronic format and their print format. This will detect both of those. The IBAN format does have a checksumming feature. These two characters can be used to create a checksum that'll prevent, kind of like the RTN checksum, that might prevent you from mistyping a code and allow machine validation. The unfortunate part is that even though it's considered part of the specification, not all the countries honor it. Some countries just fix this number, or and then implement like another checksumming feature in their own portion of the code, or do neither. So the unfortunate part is that means that if you want to implement the checksumming thing, it actually has to be done by country. You just can't have like a wide brush with it. So anyway, like I said, I went ahead and implemented all the individual countries and broke it up by their formatting, and we'll see how well the results work out there. So this is the driver's license module. Like I said, this was done by a previous student. The only thing I really did here was update it to the new format for bulk extractor, and then also added some more contextual stripping stuff to kind of tailor the results a little bit, instead of drinking from the fire hose, as it were. And then the final one was the Bitcoin extractor. There was a previous student had wrote this one as well, but this one's essentially a complete rewrite. The previous student did have a means for scanning for the actual addresses and for the wallets. Excuse me. But there is actually like a really solid way of validating the addresses, and so I've gone and incorporated it here. And so we'll see the results on that. How good we can find the Bitcoin addresses. The previous one kind of made some assumptions about randomness, whereas this one is actually really spot on to the algorithm. So the rest of these are essentially features of different types of wallets used by the Bitcoin clients. The clients allow you to interact with the peer-to-peer network and transfer this virtual currency around. So as of right now, there's several. There's some very popular ones. This one being the most popular is kind of the default client that everyone uses. But if you Google Bitcoin and then you download a client, it's probably this one, the quote-unquote the Satoshi client. But there are others. There's the Armory client, which has their own unique format for the wallet. And the wallet file contains kind of all the cryptographic information that lets you claim essentially ownership of those bitcoins to everyone else. And then this one is for the Electrum wallet. Essentially, another Electrum is another client. And the same thing for this one. This is actually from an implementation of Bitcoin J, a Java library for manipulating bitcoins or peer-to-peer stuff. And this Bitcoin J library is actually used as the foundation for a couple of different wallets. Multi-bit being the biggest one. So all right, so that's pretty much it in terms of the code. Let's go ahead and hop over and look at so we can look at some results. So to give you some idea what I've been testing on, I didn't just come up with some small files. I'm actually running against a full-blown machine, right? So it's actually this Windows VM you can see I have running here, and running against the virtual disk image for the feature extraction. So it takes quite a while. So I've already run I've already run a scan. So I'm going to go ahead and open up the viewer, just so things can be pretty. Let's see. Alright, so here we go. So I'm just going to go through, I guess, some of the feature extractors that I spoke about. So we'll start off here, I guess, with the Bitcoin addresses. So we can see here that we looks like we got a hit. Look at the histogram. Some pretty good looking ones. So we look at them. It actually looks pretty good. This looks like it's address history contacts. So this looks like it's actually from one of those maybe the contents from one of those wallet files. But is actually able to pull out the one of the addresses in the wallet file, which is pretty cool. So like I said, it looks like it's pretty trim. I don't have a whole lot of false positives. Didn't look like. Um, I think this looks like it's actually something might have been from a web page. Um, you know, browsing a lot of stuff, or maybe some other test file. But yeah, it still looks like it's a valid one. So it looks pretty good. So going on to the wallet extractor. So these are, as I said before, these are for the different various formats of Bitcoin wallets. In this case, it looks like that is from the Electrum DAT file. I believe this one is for user interfaces. So this guy is actually looks like from the Armory wallet, and that's kind of like the magic bytes you'll see at the beginning of the wallet. Bitcoin org. So this is that string is used as a network identifier in the J wallet guy. So overall, that one looks like it's pretty good. Like I said, the histogram is pretty clean. Those are all pretty much fixed strings, so kind of to be expected. So the driver's license one, this one has quite a few, still has quite a few false positives. I don't know if there's really a whole lot to do about it. It's still, it's in the middle of white space. It may just be, kind of up to, there's quite a few hits, but I don't, like I said, I was try to limit it. It is better than it was before, but I think just the actual features for the driver's licenses may just be a little bit too loose to not have this high rate of false positives. But it is what it is, I suppose. So there's the IBAN one. So here don't have a whole. I actually have pretty limited set here. Looking through it, it looks like this actually landed on one of my test files where I was working on. And yeah, so I actually have it open here, so you can see I had a bunch of test IBAN numbers when I was parsing out the regexes for each one of these. So yeah, you can see it looks like that one actually came up pretty good. Histogram is actually pretty clean. So let's see. So Perfect Money. This is one of the web currency ones. This one looks pretty good too. So looks like that guy actually might be. Maybe not this one. Yeah, so you can see I had some test codes in here when I was working on the regexes too, and looks like I found them. So that looks really good. Yeah, it looks like there's a couple in there, but yeah, there really was a couple in there. So so let's look at the RTN histogram. So this one looks like we still have some pretty high false positives. Even though those looks like yeah, so even though like those so there is a validator for the RTN code, but these do validate out to be right. But if we look and see by the looks like the fourth one, this is legit data. So this was a copy from Wells Fargo's webpage that has like a bunch of their numbers and stuff on it, and so you can see that this one looks like actually some of the browser content was pulled out. So that one's looking pretty good. And the Swift code is a little bit more dire. The actual regex tends to match too much to many common words, so even though there are country codes embedded in it, it's pretty much still kind of too high probably to be useful. The standard just doesn't have any other means for validating codes or anything like that. So I don't know. This one may have to come out too. But like I said, I went ahead and implemented the one. Go ahead and show you the ones that didn't have the best results. Just go ahead and disclose everything. So Trust Cache looks like we got one hit, and yeah, okay. So that was from that same test file over in the VM somewhere in here. Yeah. Oh. Yep, there it is. So yeah, it looks like that one's actually pretty solid. Web Money looks like it's pretty good too. Let's see. Yeah, no, it looks like that's also pulling it out of the same stuff. So, so yeah, so that's the results. So to give you an idea, I think that the hard disk for that machine is think it's like about 10 or 12 gigs, and it's pretty much full. So there's quite a bit of data. I think for this scan to run, it takes about 20-25 minutes. So some of these features are pretty solid. Like I said, there's a little bit of a deficit, I think, for Swift, the driver's license one, but they still may be of use. Like I said, there's maybe a little bit too much, but maybe if maybe a little bit more tweaking, or somebody else can come up with a clever way of validating these. But like I said, the standards just didn't really seem to provide too much, but the rest of them are looking pretty good. So, all right, so go ahead and close that. As far as like any build notes, it's pretty much no different than building bulk extractor normally. Pretty much everything is under the source directory. If you just pull down the bulk extractor code, dependencies are all the same. Pretty sure that the only caveat, I think, is maybe OpenSSL, but I'm pretty sure that's a normal requirement for bulk extractor as well. I only say that just because I had to include it explicitly here for the SHA algorithm for the Bitcoin validator. So I still don't think it's a unique requirement, but yeah. So same thing. It's if you pull this code down, the only thing that you have to do to add the scanners is go into the make file, and then you just add your scanner names. Oops, pass it. Yeah, so you can see here eCurrency, DL, Finance, Bitcoin. Those are all the scanners I added. That also add it to the build chain. If you put them so you add them there, and go back out to the top. Run the bootstrap script, and this will run all the auto make stuff. That'll put the new make files together for you, and then you just make all. So it's running config again because I reran the bootstrap, but you can see it's. I don't know how interesting it is to watch the build process, but yeah, you can see it's off and running. So yeah. So other than that, like I said, there's no other dependencies, I don't think, aside from just what bulk extractor generally requires. So alright, I think that's it, and thanks for watching, and appreciate your time.